everyone hear me? Oh, no, okay. I think it's on. Just attenuate. How's the sound? Can everyone hear me? Yeah. Okay. Yeah. So I'll just click through the timetable. Is that okay?
Well, yeah, I was going to say.
Oh, you go ahead, sorry.
Okay, so we're starting a little bit later today, guys. So I guess we better press on pretty quickly. The schedule is up there, as you can probably see. We're going to have Kevin talking about closure for about 3/4 of an hour. And then there's a few talks on more or less the output of the HTML5 hacking session that we had in AOL a few weeks ago, early August. So I guess we just got stuck in. Apologies for not giving you a very eloquent introduction, Kevin. It was over to you.
Thanks a lot. So you've seen the schedule, hashtag, Twitter groups, etc. I'm going to switch over to something for a second I want to show you. These are the closure success stories. I'm just going to start with a little bit of social proof. So to motivate the talk, why should you bother learning closure? These are some of the companies that are currently using closure. Google is not there right now. Some brand names you may know, like Akamai is there. Citigroup, which is a massive multi-billion-dollar company. Flightcasters for flight predictions, for predictions of flight delays. Some of the bigger names, at least in the closure community, are Relevance, Runa, Sonyan. So there are lots of startups there. But these are the ones that are public, obviously. So if Google is using it, I don't know, maybe it's privately being used. So there's some examples of the success stories. Also, closure is a class of languages that have become a topic of interest recently. It's a functional language like Erlang, like F#, like Scala. So people's motivation generally for learning those is that we're heading to a multi-core world where functional languages are appropriate for parallelism without having to create your threads through threading code directly. I'll just switch over my slides. I'm going to switch back to the rep a little bit as well sometimes. There's a read about print loop. So here are my slides. So Lisp reincarnated on the JVM as a 4-year-old wonder. Yes, it is a Lisp. So that might put you off, but if you can get over the parentheses, it is a beautiful language. All problems in computer science can be solved by another level of interaction. And Lisp is a level of interaction above the JVM, you could say. The primary target platform of the programming language is wetware, the brains of developers. This is especially new, a new language. So it's just over 3 years old. It was developed by Rich Hickey for about 2.5 years before public release. And then he released it, well, it's almost 4 years old now. So I'm going to cover these areas, but I'm going to fly through a lot of these. I'm just going to quickly cover these topics. So if you have an Ubuntu box, you can just, at the command line, install Closure very quickly and get down. The Closure is just a jar file, basically. But to install it quickly on Ubuntu 9 or 10, you can install it that way. Disclosure.org I recommend. If you're interested in Closure, it's a news site. It is a daily blog, or most days. And it also has a where to start page, which is really good. It has IDEs. So it has plugins for NetBeans. There are links to everything. So I'd recommend that. If you're on Mac, Closure X is one way to get installed. So you can go to GitHub, change to Closure X after you've downloaded it, and create a symlink. So that's also on other platforms, OpenSolaris, Linux, and Windows. But with Windows, you need Cygwin. One of the problems Closure has is there isn't one way to install it. So there's a survey every year, and people complain there's no one way to install Closure. It is a bit awkward on different platforms. If you're on Windows, again, you need Java installed. So do install Java first. And then CLJR. CLJR actually works on most platforms. So there's an installer. You can download a jar file and then run java.jar at the command line on the installer, and then add that to your system path. I'll publish the slides afterwards, so you can get your platform-appropriate installation. Now, all these will get you Clojure itself. I'd recommend you go to the Disclosure page, go to the Where to Start section, and get yourself a plugin for your favorite editor for Emacs or for Vim or for NetBeans or for Eclipse. Just get the right plugin. Now, also, Clojars. I'm going to show that slide for a second. It's the key thing to using any language is libraries, right? So Clojars will get you the libraries you need. So you can go here and type, for example, if I type in Twitter, I'll get Twitter jars. And then you can add those to, there's a Twitter API. You can add those to Leiningen, which is the build tool. Select the slides in. So that's for looking up libraries that people have already pre-built. That's very handy, the clojars.org site. Now, Leiningen integrates with Clojars. And it's a build tool. It's like Rake for Ruby or Ant for Java. And it gives you dependency management and it gives you a build tool. And it's command line tool. So it's built on Maven. Now, I personally hate Maven because it's so heavy on XML. Even though I'm working with XML every day right now, it's just, Maven whereas Leiningen is very brief. It's just a few lines. Whereas Maven files go on forever. You can see this is within the Java world. If you don't work in the Java world, Maven may be very alien, but mostly you don't need Maven. You can use Maven exclusively if you like. Basically, in all these cases, you have loads of options. You have loads of options for editor. You have lots of options for installing it. So there's no one single way. But I recommend you install Maven because there's some things you can't do through Leiningen. And you might need Maven for one or two things. And people sometimes build with Maven itself or with Gradle as well. So install Leiningen. Again, it's on GitHub. So you download it and you change mod it if you're on Unix or on Mac. You won't need to do that on Windows. And then there's a self-install. And there's slightly different instructions on Windows. On Windows, you can download a package, you unzip it. And I actually ran it on my desktop at work today, and it runs on Windows. It's fine, it works. So it's a self-installer. So that gives you a package management as well as a build tool. And there's a sample Leiningen file. Now, that is valid Clojure code. I'm going to go on to the syntax language in a minute. I'm just getting over the installation bits, the bits about these are all the things you need to use Clojure. That's how you can get started. So, Clojure is a Lisp, so you can see a parenthesis at the beginning, a parenthesis at the end. That's the basic syntax. And the colons begin keywords. So if you've used Ruby, Ruby has hashes or has dictionaries in Ruby where you have keywords and you can look up values. There's a similar idea here. This is just a data file for Leiningen. So it's just saying a sample project, and that's the name of the project, and you can put in the description. So let's open up an editor for a second. I'm already in Pesto, sorry. So I'm in Vim now, so I've got syntax highlighting here. And you can see the dependencies I put in for a project. So basically, Clojure core, Clojure contrib, they're just jars. And unfortunately, the red isn't showing up on that screen very well. There is red text as well. I'm better off on the slideshow, sorry. It's just not showing well. So it's all black and white here, but at least you can read it. But trust me, if you're using an editor, the thing about the parentheses is that it can be difficult to see which parenthesis matches which. If you're using an editor with syntax highlighting, the great thing is if you click on one of the parentheses, one of the brackets at the end, it'll tell you what the other bracket is on the other end. That's very important if you've got lots of parentheses. And a lot of people hate this in Lisp. You have lots of parentheses, but the editor support actually is very good because it's rainbow colored. If you're clicking on the yellow one, you know it matches the yellow one, and it shows you what the matching one is. So it's not a problem. You get over it after a while. It's like white spacing in Python. You get past it even if you hate the parentheses at first. So basically, it's just showing dependencies for the build file. I'm sorry I'm drawing this, but this is valid Clojure code, so it's a little bit of Clojure syntax. And like I say, if you wanted to find another dependency, like for example, you're doing a Twitter project, you could go to Clojars, key in Twitter, for example, and search for a Twitter jar, and then you can put in the dependency in there. You just add it into that. That's a vector of vectors. So the square brackets are vectors. And you just add in that dependency. And then when you run line, the command line, line will automatically download the dependency for you. I can show you the terminal in a second as well. I'm not going to stick back too much. So if you're a Rubyist, to install Cake, Cake is line slightly improved. The unfortunate thing is, Cake does not seem to work on Windows. I tried to install it on Windows today, and then I looked up lots of threads on Google, and it seems like nobody can install Cake on Windows. It does work on Mac. It does work on Linux. So it's very easy to install. It uses Ruby's install system, Gem, by default. So that's available on lots of systems, particularly if you're on Linux or on Mac. Gem install Cake will get it. But then, obviously, it's using the JVM underneath. The Gem is just to communicate to the JVM. So it opens up a process on a particular port. And then the great thing about Cake is over line. Line starts up a new JVM every time you run line. Whereas Cake starts up persistent JVMs, and then it sends the commands you type at the command line to the JVMs. So you're getting, it's much faster, it's much more responsive. And it does work on other platforms as well, in theory, but not Windows, apparently. So from a get-go, if Gordon Gekko wrote Software Mogul, he might have said, never get emotional about software. I will get onto the syntax in a little bit in the language itself. These are preludes to covering the language. So, but you need to get tools installed to use it. So never get emotional about software. Now, here are all the dirty little secrets about Clojure. It is a Lisp. If you hate Lisp, personally, I hated Lisp at college. I'm not a Lisp bigot. I came to this basically because I thought it's a functional language. I'm interested in it, and it has some great properties. It's very good at concurrency. It is a wonderful sequence library for processing Lisps and sequences. Here's the dirty little secrets are, though, that most of the hardcore people in the community use Emacs. There is a survey. You can look at the State of Clojure survey, and Emacs is the winner. But then lots of people are using other things as well. You can use the command line. You can use Vim. You can use any of the Java IDEs like NetBeans or Eclipse. Clojure basically is just a jar file. It's just a library for Java at its core. Clojure core, and there's a Clojure contrib as well. And then all the other modules you can download as extra jars. But if you're using Line-Ingen, it downloads those for you. You just add them into your build file. You type line deps, and it downloads all the dependencies from Maven repositories on the web. So it's very handy to use. It's a bit like using gem install if you're using Ruby, or using easy install with Python. You get all the libraries downloaded automatically. You must know some Java. I mean, it is built on Java. It's using Java strings for its strings, for example. That's another dirty little secret. It can be used on lots of platforms. Right now, I figure it's only usable on the JVM. People have experimented on Android, for example, but it doesn't work properly on Android, as far as I know still. .NET, the official line is it's not mature enough for use in .NET yet. JavaScript was officially released just a few weeks ago. I haven't done much with it. It's called Clojure Script. So it's using JavaScript as a runtime underneath. So it generates code that runs on JavaScript. And that does work. People have reported, it's rough, it's early days, but it does actually work. And I reckon Clojure is best on the server. So if you're doing server-side development, it's excellent for that, because it can do concurrency within the JVM very well without having to manually manage your threads or locks. But if you're doing this pure web development, according to the survey, most people who are playing with Clojure are actually doing web development. A lot of them are. But I think it's probably better if you have a choice of languages. I would say Python or Ruby have better frameworks. There is a framework called Composure for Clojure. It's very simple. It's like Ruby's Sinatra. It's a very cut-down, very simple framework for web development. So I'm not saying it's the be-all and end-all. It's superb on the server. But you can use it anywhere you use Java. So it's also very good on the desktop if you want to use Swing development or SWT development. So these are the other sides of this. You don't have to be a Lisp bigot. There is a plugin for anything you want to use. So you can get a plugin for Emacs, for Vim, for NetBeans, Eclipse, as I said. It's very easy to deploy. So if you're in a corporate environment, you need to deploy wars or jars or ears, you can create jars for Clojure and just deploy. You can even sneak it in. I mean, if people don't particularly care what libraries you're using, you can sneak in Clojure as a library. Just say it's a library. People are bringing it into corporate environments. So there are lots of libraries available. GitHub has lots and lots of Clojure released, but you can always use Java libraries as well. It's not viable in .NET yet, but it will be viable in other environments, I think. Particularly .NET is probably the next one I'd say we'll go for. And Clojure Script is already viable. You can use it with Clojure Script, and for example, with jQuery, for example. And I mean, it's similar to GWT. It's generating code that runs on a Java on JavaScript inside the browser, or equally on Node.js. People have used it on the server. They've generated code with Clojure Script, then run on Node.js on the server. So in theory, you could have an end-to-end. You could have Clojure Script on Node.js on the server, and then also Clojure Script in the browser. So it's generating JavaScript that runs in the browser. It's similar to CoffeeScript, which is the other new alternative for that. And you can do web development if you want to. I mean, I'm just saying, I think that Python has better facilities available right now, and so does Ruby, because they have so many plugins, for example, for Rails or apps for Django. But Clojure is perfectly usable for web development if you want to. Some of the big ideas of the language. It is the second oldest language, that is Lisp is, and this is directly an inheritor of the Lisp legacy. After Fortran, 1958, Lisp was created. It's a functional language, and it's a symbiont on the JVM. It's a dynamic language, so it's dynamically typed. Its big competitor on the JVM is Scala. Big difference is Scala is statically typed. This is dynamically typed. Another big difference is that Scala is a hybrid. Now, I don't know much about Scala. I'm not going to speak to it, but I do know that it's a hybrid. It's object-oriented as well as functional, whereas Clojure is striving to be purely functional. Now, it's still on the JVM, so you can still access Java. You can still use Java's objects. You're just not generally writing object-oriented code yourself. I mean, if you want, you can even create subclasses of existing classes. You can instantiate classes as objects. So you can do a lot of things, but it's still not an object-oriented language. It's simply running on the JVM and using Java from Clojure. So your code is supposed to be functional. And the feature is multi-core. So because of its concurrency features, because it's superb at having multi-threaded code without having to write the threads by hand, it's created for a multi-core world. So if you have a 64-core processor and you can write Clojure code that's functional, you can get parallelism working without having to hand code your locks and threads. So some of the jargon you'll see if you read the Clojure books, pure functions and no side effects. The idea of this is, again, you can do concurrency without having interference between different threads. And also that functions might be repeated. And if there's no side effects, that isn't significant. In other words, it might be run a second time if it was rolled back and rerun. Higher ordered functions accept functions as arguments. So you'll see that in the Clojure books as well. Lazy sequences evaluated only as needed. So you can actually handle infinite sequences. Obviously, it's not instantiating them, but you can process infinite sequence inside Clojure, which is very, very cute and clever. REPL. I'm going to show the REPL in a second as well when I do a quick 1 or 2 lines of the REPL. Read eval print loop. So it's like IRB in Ruby or the Python interpreter. You can run code interactively. And that's, in fact, most people who develop Clojure, they work that way. They may do test-driven development as well, but they will go to their interpreter, type a few lines, see how that's working, then put that back into their text editor. Then it's iterative that way, in the sense that they will try out code at the REPL, the read eval print loop, and then put it back into their code base. And one of the outstanding gems of Clojure is STM, software transactional memory, which is straight out of computer science theory. Basically, it gives you database transactions for concurrency, but you don't have to worry about them. It's happening under the hood. You simply wrap the parts of the code you want to be within a transaction. I'll show a very simple example of that later. I'm just going to show the REPL for a second. Okay. Sorry, I'm talking very fast, but I'll try to slow down a little bit. So there's the REPL. So as an example of very simple Clojure code, 39. So, or a println. So you can see there, it printed out, that printout is strictly speaking, is a side effect. It's not a pure function because hello Dublin GTUG is the side effect. It's printed that out. But nil is the return value from the function. So, I mean, if you look at Clojure, Clojure is all functions. I mean, if you're used to object-oriented languages, then you're expecting to see classes and objects. Whereas if you look at, let's see, that's Clojure docs, right? If you look at through the doc side, it's just all functions, basically. But they're organized into namespaces. Okay, I'll just go back here for a second. And I have a REPL here open for cake. So there's a one-liner for Hello World with swing, okay? Which just started up there. Hello World. So you can see there, what it's basically doing is it's calling a Java JOption pane. So it's a fully qualified path to JOption pane, and then it's calling a static method called showMessageDialog with 2 arguments, nil and hello world. So you can look that up in the Java docs for that Java class, JOption pane. It's a swing object. So I mean, you're just causing a class method on that JOption pane. So I'll just select these slides. Okay, so I've gone through all of the jargon. And so I've just covered the basic things. You've seen some of this already. So call a function, it has one or more arguments. So it can have a single argument or many arguments. And the key thing is that functions can be composed. So functions can call functions, or the results of functions can be passed to other functions. So now commas are ignored. It's just white space. And I think it's easier to read if you just go to the deepest nested function on the right and then see how that evaluates in your head, say, and then move back to the leftmost one. It's probably easier to understand. Again, a lot of people encounter this and find it just looks awful. But this is in black and white. If you're in an editor, you have syntax highlighting. It's not so hard to read. You can see the rainbow highlighting and see where the brackets match up. So the data types. So this is basically all of Clojure. This is what it looks like. It has true and false values, character values, backslashes, if you want to specify a character directly. So characters, just like in Java characters. It has keywords. So keywords allow you to get into your maps. So it's just similar to Ruby with keywords, with colons. It has lists. So list means list processing, or at least that's how it's glossed. So that's an essential data type. And it has maps. And you see the maps have keywords and then values. And the commas are optional. Commas are just white space. So then a nil value, which you saw that returned from a function earlier. Numbers can be floating point or whole numbers. Sets, see the difference between a set and a map is you prefix it with a hash to indicate it's a set. So obviously, the values are unique. You can't repeat values in sets. There's some others as well, like there's sorted hash maps, and there are a few others, but these are the essential ones. Strings are just Java strings. It's just from the Java runtime. Symbols are basically symbols is just a way of saying names you'll find that in other lists as well. It's just, so that's a symbol, Java lang.string, which is straight out of Java. But any kind of name for your function or a name for a class that you're calling in Java. Vectors, similar to lists, they have slightly different properties, so they have slightly different performance depending on what you're doing. But you'll notice lists, maps, sets, and vectors, they're all sequence types. And you can apply the sequence library to those. The sequence library is, I think, the most powerful part of Clojure if you don't count any concurrency on the STM. It's just, you can do an awful lot in a very few lines of code with the sequence library. That's what I really loved. There's a whole chapter in this book about it. When I was reading this, it was just a revelation, programming Clojure. I'll go through the books later as well in a second. So control flows. So conditionals. So you can define danger to be true. So you've got a Boolean value. If danger, println, sound the alarm. So it's fairly simple. Danger is true, so you will sound the alarm. Or another one, def cost 10, and the conditional, if the conditional is, if it's less than 100, you println cheap. So cheap will be printed out if I run this at the REPL. Or if it's greater than or equal to 100, you println expensive. It's very simple. Print cheap in that case, since it's less than 100. So there's a couple of examples of if statements, or an if-else statement, effectively. Iteration. Now, iteration isn't really idiomatic in Clojure. I decided to give an example of it anyway. I'm using the do times function. And do times, so the arguments are inside the square brackets, because that's a vector, but that also means arguments in Clojure. The arguments go inside square brackets. So the do times is a built-in function in Clojure. And basically, it will start the counter at 0, and it'll run it up to 3 minus 1. So it'll run through 0, 1, 2. And on each run, it's going to execute the function inside. So println loop run. But inc is simply returning the value of counter plus 1 each time. So it's going to return 0 plus 1 the first time. It returns 1. It returns 1 plus 1 the second time. It returns 2. And the third time, it just returns 2 plus 1, returns 3. So it's just increment counter. But keep in mind, always keep in mind, everything is by default is immutable in Clojure. So nothing is being incremented. So there are different values each time. There are no real variables in Clojure. It's the key thing. You're binding values to names. You can call them variables, but you really can't vary them unless they are atoms or refs, or the types I'm going to talk about later. The types that are immutable. The types that are immutable you dereference them as a little. I'll show them in a later slide. But basically, by default, everything is immutable. When you actually say you're mapping something to something else, you say you're selecting, for example, from one list to another list, then you're creating a new list for the result set. You're not changing the original input value. It's something new is created for the output. So it's similar to the idea that in Java, strings are immutable. You create a new string from concatenating two strings, for example. So anyway, like I say, iteration is not idiomatic, but I just had to give an example anyway. Working with Java. You can import any Java library you like. So this will be at the header of the file. So in that case, I import java.io.file. And the quote is just so that it isn't evaluated. Quote is also in other lists. It means don't evaluate what comes after this. Then string dot means instantiate a string object. Okay, that's the brief syntax for it. And I could define that as well. And then I could give it an argument and populate that string with something. Dot next int, the dot there means, and followed by something means call a method. So I'm calling that next int on a rand. That could be a random object, a random value I've generated with a previous function. And I'm calling next int on the rand to get the next integer from a random sequence. There's some other ways of calling Java, but they're the basics. There's also a proxy where you can create subclasses of other classes. And then, for example, if you needed to pass a parser, that's an example in that book, that if you needed to pass a parser for XML to something, you could create a subclass of how you want, so that you show how you want it parsed. But I mean, in most cases, you're just using Java objects as opposed to dealing with classes or creating new classes. So you're programming functionally, just but on top of Java. So they're the essentials of calling Java. You just instantiate new objects with the name of the class followed by dot. And you can call methods within the class by calling the method name. So next int is a method name on the object. So sequence library is a part of Clojure. And what's great about it is how widespread it is. You can use it on all Clojure collections. That's maps, lists, vectors, hash maps. Oh, no, sorry, maps and vectors and lists. The fourth one is. And Java arrays and strings are also seekable. So this means you can use the sequence library. Sequence library can do things like it can filter for certain values. Basically, all the functions work across everything in your list. So if you have a list, for example, apple, pear, could be 1,000 long, you could decide you want to search for all the ones that begin with P, or you could filter for just the ones that begin with P, and then create a new list that has just the P ones, for example. But of course, the original is immutable. It's the new one is created out of whole cloth. And the sequence library you can find it on the Clojure Docs website. It's a huge library, and it applies to all these types. So XML data, directory trees in the file system, input-output streams, regular expression matches. So anything that implements the iterable interface. You can create new classes in Java as well, implement the iterable interface, and they'll be sequelable as well, meaning you can apply the sequence library to them. Like I said, the sequence library, it's very powerful for processing of data. And that's something that Clojure is very good at. It's very good at big data processing. Their whole conference is now devoted to big data, and Clojure is very strong in that area. For example, Hadoop. People have written libraries for Clojure just for Hadoop. And some of the other projects I'm going to mention later cover, like Incantor is a statistical library for Clojure, also very powerful. So these are some examples of using the sequence library. I need to import the java.io file. I'm going to switch over to REPL for a second. So I've typed out some of these already just so I can quickly run them. So I need the file object in order to run sequence. That's why I ran this earlier. Okay, so that's been already run. Now, if I count file sequence, what's happening with there with the count? I don't know if you can see that. So it's a count method followed by file seek. File seek is a built-in function, and then file dot. So basically, it creates a file dot means create a file object. File is a built-in class in Java, well, java.io.file. And the argument is dot. Now, in that case, dot means something else. Dot means the current directory. So it's the literal current directory. So the final set of brackets means create a new file. The argument is dot, the current directory. So it gets you the current directory. And file seek is passed the output of that first function. So file seek means it seeks over the entire file system below the current directory. So it's getting you access to the whole directory tree. And then count just means count everything that's in it. So it just tells you all number of files underneath. So 78 files underneath. That's including directories, of course. So another example is, so this one is a more complicated example. Okay, Now, the sequence library is much more broad and general than this. There is a vast number of functions. There are whole chapters in the Clojure books about the sequence library. This is an example of what you can do with it. So again, I've created a file object on the right with file dot. So it creates a new file object, passing in the dot current directory as argument. So it gets me the current directory. Then list files is a built-in Java method on the file object. You call list files on file. That lists out all the files. It returns an array. Now, array is not a built-in type in Clojure, but Clojure has very good integration with Java, so it can deal with arrays. The next thing that you do is seek is another built-in function in Clojure. It turns that array of files into a seekable. So it means you can apply the sequence library to it. Now, in a lot of cases, you don't have to run seek. It's automatic. For a lot of the other types that I mentioned earlier, you can run them without running seek. But in this case, you need to transform it into a seekable. So the sequence library can use it. Now, map is a very powerful built-in function in Clojure. It means apply the following function to the following argument. So the hash there means it's an anonymous function. So it's applying .getName to the argument. The percentage is an argument. So it applies .getName to all of those files, and so prints all the names. Or, so I'll just run that anyway. So the output. So I've got a list returned. Well, it's printed as a list of all the files in my current directory, basically. So what it's done is it's mapped that anonymous function of getName across all of the files it got from the current directory. So there's an example, but there are far more powerful examples. You can keep nesting them and nesting them. You can keep applying more and more functions, and you can get a great deal of power in just a line of Clojure code. Whereas, imagine what that would take in another language. That's what I really love about Clojure. So, okay, go back to the slides, please. So you can maybe see those code more clearly on these slides. Okay, so I've got the same code here, but it doesn't have the same highlighting. There's another one there, do times, which is a similar idea. In that case, yeah, I won't go through that, but it's just using iteration instead. So I'm going to just cover concurrency very simply. There are whole chapters in the Clojure book on concurrency. It's quite a complicated topic. But here's a simple treatment of it. So the reference types are mutable references to immutable data. Okay, so remember, everything in Clojure is immutable by default. You can't change it. So you can create it, and then you can process it. But whatever you process, the output will be a new object. And then the next will be a new object. And the way it gets over the problem of running out of memory is that if there's only a very slight change, supposing you have a very large object, let's say a gigabyte in size, you make a small change to it. What it does is, from your point of view, you have two different objects. But in fact, in memory, it's storing the delta. So it's storing the original object and a delta for the new object you've created. And therefore, the extra memory required is very small. It uses persistent hash trees, or I can't remember what they're called, persistent trees for those anyway. But that's under the hood. You don't need to worry about it. The four reference types are var, ref, atom, and agent. They're used in different situations. I'm going to cover an example with a ref. These have different properties. With agents, you can have thread pools, for example. And refs are synchronous. So basically, you run transactions with refs. But all of them they're all mutable, whereas everything else in Clojure is immutable, as I said. It can be any kind of data. So it could be a list. It could be a vector. It could be just a string within one of these reference types. Or rather, it's actually pointing to the immutable data. So it's a mutable reference to immutable data. So it's a bit like a pointer. If you use C, you can dereference and get the value just by having the at. Macros are all over Clojure, and a lot of times they use symbols to use the macros. And dereferencing will basically get you the value that's inside. Like I said, it uses software transactional memory. This is the secret sauce of Clojure. It gets you concurrency without threads by having a transactional system. So this is a very simple example of using a ref with software transactional memory. So I define a forecast with a ref, and the ref is pointing to a string. So very simple data. Sunny with scattered showers. And that goes, so the ref is now pointing to a string. The string is immutable. The ref is mutable. So I can change the ref, but only inside a transaction. If I dereference it with @forecast, I'm getting what's inside. So sunny with scattered showers is the output. If I run that without dosync, the following piece, it will fail because it will tell me that there's an exception. You can't change the ref outside a transaction. What do-sync is, it's wrapping it in a transaction. So it gives you ACI properties. With databases, you're familiar with ACID properties. It's atomic, it's consistent, it's isolated. The durability you don't get because obviously it's in memory. If someone pulls the plug, you don't have durability. But it is atomic, it's consistent, and it's isolated. So it means that what happens inside the do-sync is isolated from other threads, and it can be rolled back if two threads collide, if both try to access the same ref at the same time. And so you can do a ref set on the forecast. It assigns torrential rain and thunderstorms, and then you dereference the forecast, and you get the output. So, but that can only happen inside a do-sync, because refs aren't allowed outside do-syncs. So do-sync puts it inside the transaction and allows you to change it. But that's a very simple example. You could do far more complicated things. Otherwise, you can't change data in Clojure, unless using one of these four types, refs or atoms or the other two var. So multiprocessor concurrency. So that example is within a single JVM. There is a project called Swarmiji, which Amit Rathore has created for multi-process concurrency. So if you want to go outside the JVM, you want to go to multiple machines. Say if you've got a swarm of Amazon EC2 instances, you could run Swarmiji and have processes on each. But Clojure itself all of its concurrency is aimed at a single JVM, whereas Swarmiji is aimed at multiple JVMs. But of course, Java has many, many other libraries for multi-process concurrency, like SOAP, XConfPP, Corba, Terracotta, etc. Some advanced features. There are actually more advanced features I'm not going to cover, like protocols, which were released, I think, in 1.1. But I'm just going to cover a couple of macros and multi-methods. There are actually lots more features for concurrency. There are futures and promises. There are agent thread pools. I'm just covering the surface and give you some idea of what Clojure has. So basically, macros are code that generates code. All Lisps have macros. And basically, I mean, there are two phases. There's a macro expansion phase and an execution phase. And here's a macro for unless, so a very simple macro. So a def macro, whereas a function has def n, and if you're defining something and binding it to a variable, it's just def. This is def macro, which is a special keyword for macros. I'm defining the macro unless, which has two arguments, expression and form. So the arguments go inside square brackets, the vector brackets. And then the body of the macro is a list, which is just if expression nil, so nothing happens. But if it's false, then you execute the form. The form means in Lisp basically a piece of code. Like that whole thing is a form. So def macro unless is defined there. It's expanded here, so it's easy to understand. So def danger false. By default, if I find false, define danger as false, then unless danger, println open the door. So danger is false, then will you open the door? So it expands if danger nil and println open the door. So because it's false, you open the door. So that's the macro expansion phase. There are far more complicated macros where you can insert variables as well. And then you're using special syntax for that. But basically it means you can write code which writes itself, or at least which changes at runtime. So people rave about macros. If you read Paul Graham's essay about encouraging people to use Lisp, he talks about macros and the power of macros. It's an advanced feature. You don't have to use macros at all. You can write lots of Clojure code without writing macros, but it's a powerful feature you have in your back pocket if you need it. Multi-methods are another advanced feature, and again, not widely used. You don't have to, it's only used I think 4 times in the Clojure core code I've heard. And there are 2 stages to a multi-method. Multi-methods are a bit like polymorphism in object-oriented languages. Okay, so, but it's not just on the. What I will do here is I'll re-implement polymorphism. So I'm doing something different based on the class of the input. That's basically what polymorphism is. But what's powerful about multi-methods is they are more powerful than polymorphism. They're based on any kind of function, not just the class. So here, def multi says gen welcome message is based on the class. Class is a function in Clojure which returns the class of an object. So if I pass in an object to class, I get back, for example, it's a string or whatever class it is. So then the method, you have several different methods for that multi. So gen welcome message user, and then I print hello, and they get the name of the user. So it applies .name. That means to call the method name on X. So get the name of the user. But for a different class, for admin, now user capitalized, that's a user class in this case. So it's selecting which welcome message implementation to run, which multi-method to run, based on the class, whether it's user or admin. So what happens is, at runtime, there's a runtime dispatch where it applies class to either user or admin and then selects which method to run. But you could have many more implementations as well. You could have many more objects, many more classes that it applies to. In the second case, it's gen welcome message. That's another method. If admin is the type of the class you pass in, then it prints red carpet treatment for you, and then prints out the name of the user. So I've got more information here. So if it's a user object, it just prints out gen welcome message, hello Jim. So the user one was executed. That's a very simple example, again, of multi-methods. But you could have far more complex examples with many more multi-methods, many more implementations. You could all use something else beside class. I use class as the function to select which of the methods to run. But I could have picked something that selects based on the color or the size or on any property of the object that was passed in. So you can have runtime dispatch based on just about anything you like. Like I said, it's not a widely used feature, but it is a very powerful feature in Clojure. So again, there's a whole chapter on this in the Clojure books, so at least in the basic ones. And quickly go through what web development involves in Clojure. So Composure is the leading web framework. It's very like Sinatra in Ruby. It's inspired by it. It's generally used with a Ring middleware underneath. Composure can be used in App Engine. App Engine is a huge limitation, which is it's single-threaded within a JVM, which severely cripples Composure, but it still runs. If you're running a little application with Leiningen, you can add in that as a dependency, and it will download the Composure library for you. So you could go to Clojars, type in Composure, it'll give you a version. Now that's quite an old version. I can get a more recent version. There's some sample Composure code. That's a valid file of Composure code. So I'm just going to open that up somewhere else. Let's see. So the problem is the red is not showing up there well. The syntax highlighting in Vim. But I'll open up. Oh, yeah, good point. That's a good point. Thank you. Colon syntax all. Thank you. Colon. That's much clearer. Thanks a lot. Will that be persistent if I open up another Vim? No? Okay, right. Good point. So that's the same code again. So I'm just going to run. I'm just going to run it with Cake. Like I said, Cake is like Leiningen. It's the build tool. It uses the same syntax for the files. It uses the same project.clj files, but it has a persistent JVM running in the background, so it should be faster. Okay, so now it's started up on 8082, and if I go to 8082, then hello Dublin GTUG. But I'll show you the code for that again. So this is a very simple Composure file. First of all, there's a namespace at the top. There's no specifics. Can you read that? Or is it? No, it's the red is still invisible. So. Okay. So NS means namespace, and then it has, basically it's bringing in the libraries it needs. Composure Core, and it has an adapter for Jetty. Jetty is the servlet engine for Java, and Ring has an adapter for that. Ring is the middleware, and then Composure runs on top of Ring. And then use and require are basically slight variations on importing Composure libraries. And there are two functions. One of them defines the roots. If you're familiar with Sinatra, it's very similar in Ruby. And it defines the root, which is, if you get the root, then it's hello Dublin GTUG, and just has a simple line printed out. And then if nothing is found, then a page not found is printed out. So they're the two routes that are found. You can find many more routes. And then run Jetty just starts up the Jetty servlet engine at the bottom on port 802, and you can see the output over there. I'll switch back to the slides. Okay, so that's the code again. So that's a full Clojure file. That's a valid Composure web app. So you can do templating as well for web development. NLive gives you a domain-specific language. So basically, you can construct Clojure code and convert it to HTML. Because obviously, Clojure is like a tree in itself. You can create a whole HTML page in NLive and then run a function that which outputs the HTML equivalent. Personally, I don't like that. It's a matter of taste. You can certainly do that. I prefer Fleet, which is more like the template you might have seen for PHP or Perl or Python, where you have raw HTML, but you can insert functions in the page and print out the Clojure data you want. But it's a matter of taste, which you might prefer. So there are two options for templating. There are some others as well, popular ones. If you want to run your blog on Clojure, Lau Jensen is a European Clojurian, and he has released his blogging software open source. So if you go to his GitHub site, you can get the blogging software and download it. Now, there used to be blogging software for Twister as well, but I think he's taken it offline. But Twister is a little web framework. It's just a tiny homegrown framework that runs on App Engine. You can build it from scratch, and the blogging software is no longer there, but it is a nice little web framework. I've run it myself. You can also run Composure on App Engine. But like I said, the big limitation is single-threaded. So this is my appeal to Google. Please implement this feature. It's not a very popular feature right now. It's basically providing concurrency for Scala and for Clojure. So the JVMs are single-threaded on App Engine right now. But if they were multi-threaded, if they could support those features, it would be very cool for Clojure and Scala. So I've got some slides here for reference mainly. So the other platforms beside the JVM, .NET is out there, but it's not really usable right now. It's not mature. Clojure Script has been released. It's like CoffeeScript, as I said. It compiles down to the Java runtime. There's a whole video that was released just a few weeks ago, I think, I don't know, 3 or 4 weeks ago or so, about Clojure Script when it was introduced to the world. It is ready for prime time, but it's very young still. And you can use it with jQuery. You can also run on the server with Node.js, as I said. And don't confuse it with Clojure with an S. So Clojure with an S is Google's optimizing compiler for JavaScript. And funnily enough, Clojure Script uses Clojure with an S as part of its system, so that's even more confusing. But I would prefer if the Google space was not polluted, but unfortunately it is. That's the history of Clojure. 1958, Lisp was created by John McCarthy. 1995, Java was released by Sun. Just under 4 years ago, after about 2.5 years of private work, Rich Hickey released Clojure. So it's under 4 years old now. The current version is 1.3. You might have seen in my slides, I'm using 1.2 still. I haven't upgraded to 1.3. So presumably 1.3, the final release will be fairly soon, I'd say. The state of Clojure, it's a vibrant global community. I mean, people are very welcoming. It's a proud language, and there's a lot of enthusiasm about it. There are 4 published books. I'd recommend this one. I'm going to show a slide about it as well. Programming Clojure. It's one of the best tech books I've read. It's a superb introduction. It's full of examples, all of them one-line examples you can run at the REPL. And it is a whole chapter on functional programming. A big part of learning Lisp or any of the functional languages, thinking functionally. I mean, thinking about mapping functions all the way across whole sets of data. You know, start thinking about recursive functions and getting away from variables, getting away from mutable data, because you have very few mutable objects within a Clojure source code file. So Clojure.org is the open source development site. Clojure.com is a training consultancy site. And if you want to see the 2011 State of Clojure survey, you can see where, it's very interesting to see where people have come from. Like most people come from Java or Ruby or Python, which are the 3 languages I know best or have used most. And people are mostly using Emacs. And most people have only taken up Clojure very recently. Because it's such a new language, it's growing so fast. You can see all the survey from hundreds of developers. Just came out a few weeks ago. So some of the notable open source projects, Crane allows you to manage processes on Hadoop and Amazon EC2. So it's a big data project, basically. Incantor is for statistical computing and for graphics. Also a very cool project. And Palette is for provisioning Amazon EC2 nodes. So they're all very great. They're great projects in open source for Clojure. And this is the book I've just been showing you, Programming Clojure. This book was the first one that came out over 2 years ago. It was the first one I got. And it is superb. I highly recommend it. Even now, it doesn't obviously cover the latest features, but it's the core of the language. It'll get you started. And you really need to read this or one of the other ones. You need to read this or the next one first, because the other books are more advanced. So I'd recommend start with this, one of these two. This one came out more recently, so it's more up to date. It covers more of the later features. But it's more brief. It doesn't have as many examples. So I actually recommend this one maybe more. It is longer, but it gives you more examples. It builds up an example chapter by chapter as well. This one is also very good. I read this one as well earlier this year. This one, it's no longer in the early access. So I've got the Me app on the graphic, but I believe that's been fully published now. I have a copy of that as well. I haven't read it in full yet, though. It's more advanced, though. So I would read one of the others first. And that's by Amateur Thor. He's the sorry. The next one's by Amateur Thor. This one's probably the most advanced one. Joy of Clojure. It's by Fogus and Hauser. So read that one. I'd say last of them if you will read them. But it is superb. It's garnered a lot of praise. Clojure in Action is by Amateur Thor. He's the creator of Swamiji. That's the multi-process project I mentioned earlier. And he's the one of the chief technologists in Runa, which is one of the startups using Clojure. He's in Silicon Valley. That's also excellent. But again, that's a more advanced book than it. The two Manning books, Clojure in Action and The Joy of Clojure, I assume you read a previous Clojure book before. So start with one of the other two, I would recommend. So this group is almost dead, but if you want to join it and enliven it, you can. There is a Clojure Island Google group, but nothing's happening on it right now. If you don't get the books yet, you can go to tutorials. There are tutorials by Mark Volkman and by Satish Talim. And the Volkman tutorial is very comprehensive. He's revised it repeatedly. It's a very long single web page. So if you're prepared to dig into it, it's very heavy though. It's very condensed. So it's much easier to read one of the books. I would recommend. I haven't read the tutorial in full. It's really too heavy to read. It's easier to read the books because they have examples and there's more text in them. But it will take you longer, obviously. The Daily Digest Disclosure is excellent because it covers all the releases, all the new libraries, all the news about Disclosure, and all the conferences. And it's gathered from Twitter every day. The best starting page is the Where to Start page on Disclosure. It gets you all the tools and gets you all the plugins for your, gets you Leiningen, Cake, all the links. So my conclusion, Clojure is a powerful, functional, dynamic language in the JVM. It's built on lots of ideas from computer science, like the software transactional memory, like persistent trees in memory. You can use all your existing Java code base. You can use jars, use wars. You can deploy to Java environments like Jetty or like Tomcat, etc. You can use the libraries and tools of the Java world. So it's very easy to call Java code from Clojure. And you can reuse NetBeans or reuse Ant or Maven, etc. You don't have to write your threads by hand. If you want to, you can still write thread dot and create a new thread. But you don't have to. You can use refs, use atoms, etc., and use agents with multi-threaded, with agent thread pools. And Clojure is not your grandfather's Lisp. Lisp is over 50 years old, but this is the reincarnation. Okay, thank you very much, guys. Thanks. Sure, yeah. So it's designed for inside a single JVM. All the concurrency features inside it are for within a single JVM. If it's multiple instances and multiple processes, it's not handled by Clojure's own native concurrency features. So like I said, there is a project called Swamiji, which does handle multiple processes on multiple machines, for example. So you can use that, but that's not the focus of Clojure as a language. Clojure as a language is within a single JVM, and it's managing its threads under the hood without you having to write your threads by hand or do locking by hand. So.
What if some of these data, some of these threads are generating data, some of these threads are reading data? You want to somehow synchronize all of this. It doesn't seem like something the language would be able to take care of.
I don't think it's going to take care of all your problems, but it will take. You don't have to write any locks, though. That's a key thing, and you don't have to generate. You don't have to create your threads by hand. But certainly, you have to design your concurrency for that particular problem. But the basic strategy is everything is immutable by default, and you just decide the particular pieces of data you want to be mutable. You tag those, you make those, you reference them with atoms or with refs or one of the others, and then only those ones are mutable. Everything else is immutable, and that allows a lot of concurrency in itself. And then, so multiple threads can be accessing things concurrently, obviously, if they're read-only. And then beyond that, though, you've got to design it for your own problem. You've got to decide what will be mutable and what you want managed by Clojure. You may have to manage some things yourself. I haven't tackled the particular problem you're describing with Clojure, so you need to examine that with the features the language provides. It's not available yet, but it's in Java 7, I believe. So it's not, that is a bugbear, all right. It's not available yet, unfortunately.
I think it should be, yeah.
Can you hear me on this?
We'll start up again, I think. So we're running a bit behind time as usual, so we'll probably leak out after 8:30 this evening. So there's 3 more short talks to go on demos of stuff that the guys managed to get working at the HTML5 thing that we did earlier on in August. So Brendan Wise is up first, going to talk about crowdsourced traffic events using HTML5 and geotext API. So,
Sean, can you hear this, yeah? Mike? Cool. So this link here is just something I created to demo what we actually use. And if anyone actually tries that, and if you're surprised, what it does is in HTML5 there's this geolocation API that allows an internet browser access to your physical location of the machine that you're using. Now, personally, I only discovered this in November. I was browsing a mobile site for hyperlocal news, and it asked me, can we use your physical location? I said yes, and it knew where I was. And I was surprised because the fact that an internet browser was using something with the hardware on my machine, which didn't have GPS, it was just a MacBook Pro, and it knew where I was. So it was surprising to me that they could do that in a browser. And the way they do it is it's by Wi-Fi signals and stuff like. So you've here they're going around getting information from maps and stuff and gathering information on Wi-Fi networks, and that's why they can use Wi-Fi networks. Also, if you try it on a phone, it's going to use the GPS or whatever is available to it. Why would they want to use that information? And it's the kind of thing like Yelp or Foursquare or any of these, the sites that offer you local services. It's handier for them if they know exactly where you are. Of course, there's lots of other. And what if you think this is really, really bad for privacy? Like why I don't want them to do that. Well, they are required that before they use your physical location, a little menu bar will pop up. We want to use your physical location, and you go yes or no. And accordingly, you won't be able to use the parts of the site that need that. So the way it's done very simply is this navigator geolocation object in JavaScript. You call get current position, and you can get these kind of attributes here. Any browser, I haven't tried too many browsers, but you will always get latitude, longitude, accuracy, and I haven't seen any yet that provide these heading or speed. I even tried on the browser on an Android phone, which would not, you can tell that from the compass that it does have a heading, but it doesn't seem to provide it in the browser. So here's an actual demonstration. And the link I had on the very first slide does something like this, and it just calls navigator geolocation get current position. And on success, it comes back this function with a position object, and you see position has coordinates, latitude, all the other things I mentioned, and also a timestamp. A second thing you can do is if you want to be continuously aware of updates, you can just call watch position and give it a function, and that function will be called every time there's updates, and you have some options regarding the kind of updates you want, so that if you want high accuracy, you're going to get more, if there's GPS available, it's going to use it, or you can also set as timeouts or the maximum age of the location you're willing to accept. So our project was to produce a demo using this API, and we thought it would be cool if it was somehow related to traffic events, and we wanted to use geolocation messaging, an existing geolocation messaging API for the back end to save us having to worry about that. And the project we came up with was to use the user's motion to determine their traffic speed, assuming that they're in a car. Also allow the user to alert other users in the area for stuff like accidents that they're aware of, and to represent this graphically on a map. So I have time, Sean, to just a brief demo of the actual project. So this is one screen. If I just, for a sec, the original link that I put up is this. So this is the timestamp that tells you this wasn't updated. It's 3 o'clock today. I have this link to Google Maps just to show exactly where this thinks I am at the moment. So it's somewhere around it, Dublin Castle there. So bearing in mind that's where this is the tool that we developed. And bearing in mind that's where it thinks I am right now. Except if I just take this off, I'll explain this section. So here's what we came up with basically. It's this map, and it's using that physical location. That's where it thinks my MacBook Pro is right now. It's not very accurate, but it doesn't have GPS. The idea is I can report an accident at this location. It'll pop up here for me, but others in the area would also see this, and that's what our API does. Just to give a better demonstration. This is one of the things with this location stuff. How do you actually, how do you test it? And we found that as part of the project, we were lucky enough to have a very good JavaScript guy with us, Gar Maguire. And what he had to do was, in place of the geolocation API, simulate a guy walking along or traveling along this road, simulating the traffic being slow, him coming to a stop and then moving on again. If you've used Android phones, you know that this is kind of thing is built in. You have KML files, which are locations. You can simulate and mock locations along a route. We couldn't find an easy way to do this. So I just kicked this off. That should move this. Right, so this seems. So that's simulating a guy that's traveling along. I'll just have to open another instance now here. And here's where I can see this in this separate tab here. So that simulation is running. This is the user moving along. These all are events that would typically use the geolocation API, and we get stuff like that. But very simply, that's what we did. So how it works is I use the watch position function to request updates, so we always know the current user's physical location. Then we notify others through an API of any changes in speed. I mentioned earlier that the speed attribute is available sometimes in this geolocation API, but only it seems it's optional. So in our case, Gar, our JavaScript guy, had to use the previous location and the time and work out the user speed and then determine traffic. It was only a demonstration. We had a button there for reporting accidents, and then we just, as a user moved along, we updated our current position on our API. And then the other side of it was that you would query for events in your area in a certain radius that had been posted up by other users. Issues we found, like I mentioned, the geolocation API. I mean, how do you test this kind of thing? We had to spend a lot of time writing a simulator, Garrett, to put in all the locations, the latitudes and longitudes. Like I mentioned, in Android, that's easy. You can mock a route, and then you can just run that route. And obviously, in older browsers, all the major browsers now do support it, but older browsers don't. Briefly, the backend, as I said, it's something that existed already. It's something that I worked on. It's why I was interested in a project like this. And it's just an API for storing messages with latitude and longitude, and you can categorize them. It's intended to be used for purposes as we demonstrated there, because I had a site, cbri.com, that uses traffic information from AA Roadwatch, and I need a way of crowdsourcing that information instead. And that uses MongoDB, which has this cool geospatial indexing, and you can call stuff on a database like that, and that's what we do. And it's Ruby behind it. There's a link to that, the demo of what we produced. That's it. If there's any questions? Oh, thanks.
So I think, who was up next? Owen? Was it Marcin, or was it Marcin? Was Marcin? Oh, he's hiding down the back here. Okay, so next up is Marcin Olak, who's going to do a talk on some of the pretty cool stuff that he did with the audio capabilities of HTML5. So, up to you.
Do we have audio inputs here? Sorry, do we have audio outputs here? Oh, that's a good question. So, yeah, okay. I'm not sure if this is the correct one.
Yeah, it is. Try again. Okay.
So, can I use this one? Hi everyone, my name is Marcin Olak. I'm going to present output of a small project that me and my colleague Monika, sitting over there, hacked over weekend in the beginning of August. We decided to play a bit with part of HTML5 audio API, which turned out to be pretty cool, although not designed entirely to the purpose we tried to use it. So I'm going to tell you about this project. Then, yeah, here's the presentation outline. Some goals that we tried to achieve.
I'll make a short overview of HTML5 audio and play a bit in console of Chrome with this. I'll comment on some challenges that we've met. I'll show the demo in question and summarize what I've learned over the weekend. Yeah, great. So Monica is the co-author of the project. It was 2 days worth of work. What we tried to do was a so-called drum machine running in a browser. Drum machine is basically an electronic musical instrument. It combines a sequencer and some sampler. So sequencer is just a music controller. It tells you when and which sound to play, and the sampler just uses these commands and plays the requested sound. So for the UI, we used HTML and CSS. For the logic, JavaScript, of course, and the sound generating part is, of course, HTML5 audio. So just a short overview of HTML5 audio. HTML5 audio is part of HTML5 media, which is pretty cool if you go to the specs of this part of standard. It has quite extended list of events that enable you to control over what's going on with the audio stream and video stream. After my 2 days of playing with this, I can think that probably it was mostly targeted as replacing Flash media players from the browsers. With this API, you can implement very neat media player with actually all of the features you want. Also, probably business related, like playing ads between movies and so on. So the API allows you to do all this. We used only a small subset of this API. So the subset we used is basically audio tag. It's of course object that can be represented by optional user interface controls in the DOM, but it's completely usable without being placed in the DOM, I mean. I use basically play function, and that's pretty much it. Also that's not entirely true. I use play, some simple event, and load. So only three small features of audio, HTML5. So I want to show you how to use it. It's actually very fast. You can start programming HTML5 audio apps very fast. You just need to have, just bear with me for a minute. Yeah. No luck. I'm trying to open Google Chrome here, and hopefully, yeah. So I'm not sure if you see the console part here. Yeah, that'd be tricky. That will be tricky, but I'll try. So this is how you create audio tag. You can point it to some media resource, and you're ready to go. So easy. Well, you can also create other media resources and play with them as well. Yeah, so music is a sequence of sounds, as you probably know, and we went through this path, and we created an app that utilizes this. But there are a couple of interesting things even with this small example. First of all, this little object is there are two things. One thing is it's a representation of the media resource. That's pretty obvious. But the other part, it's also a representation of the player associated to this. So, for example, you can actually put it into the DOM. And, well, play is just what's being invoked when you hit this. So actually, you're not able to play the same sample twice, using the same instance. Here's the small example that shows this. I hope parentheses are fine. They're not. Can someone, because I don't see it from this. So once again. So is there an error already there? So with 20 milliseconds of delay, you should actually hear reverb, metallic reverb. It's not exactly what's happening. This is because when I issue play, there's the instance of player associated with the sample starts outputting the audio. So what we can do, of course, is to use different instance here and associate the same media resource to it, and it will have the effect that we want. Right? Yeah, that's it. Oh, it's actually it's yeah, it's a low frequency sample, so it's a bass sample that reverb is not very audible. But this is the approach that we used. Every time we want to play a sample, we create a new instance and make sure that the garbage collector removes the instance from memory as soon as it's finished playing. When you don't do this, after like 200 instances of audio tags, the Chrome browser crashes. So you have to do this. So yeah, so this was a short exercise of how to start with HTML5 audio tags. Couple of challenges that, here's our previous attempt to do this. We utilized the same sample and actually tried to stop it here. Actually, HTML5 audio does not have stop function. It has only pause and play. So when you issue load, that's the only place in specification that tells you that actually specifies that the sample should be stopped. So you can use this as a replacement of stop. And sample being able to play overlapping, in a short period of time. So this is exactly the snippet of code used in the demo I'm going to show you in a minute. We when we want to play a sample, we just play it, and we also add an event listener to it, and probably it should be added before, in case it finishes before. So we add event listener, which fires on the event ended, and then, according to the specification, this is a hint to the browser that object is ready to be garbage collected. So I'm almost finished, but I realized that you probably have no idea what was the app I was trying to make at this time. So maybe I'll show you, and it will make it all clear. So in this row, in rows you have instruments, and in columns you have buttons that trigger the sample play of the instrument. So when you start the sequencer, yeah, it's all fine. It's just screen is too small. So I think it's very easy, straightforward what's going on here. Whoa. Let me refresh it again. Ah, it was more spectacular the first time I presented it. It was oh, that's the worst demo I've ever made. Let's try to change audio toolkit. Maybe this will help. Yeah. Yeah. So let's make some basic rhythm. So after this presentation, you will know how to use HTML5 and how to recognize 3 sample beats popular now in the recent music nowadays. So this is sample dubstep beat. And I think you recognize this. Yeah. So we can also program, of course, breakbeat. I have this program type. Yeah, so this is simple breakbeat beat. We have also tempo adjuster here, and it's suddenly hip hop, old school hip hop. So there's also shuffle, which adds some swing type sound feel to the beat. What it does is every second note it adds 25% delay. So yeah, that's the shuffle. I think it's better heard when you add this. Sorry. Oh, yeah, that's the shuffle. Yeah, I forgot to warn you that it will be not a very technical presentation because the audio tag is very simple. So yeah, this is what it does. Well, we also used local storage to store this, but it has even simpler API, so it's not fun to talk about. Okay, so what I've learned thanks to this hackathon is that HTML audio API is pretty cool, but it's kind of targeted at letting people implement media players. If you're trying to do something else, you have to kind of bend it and stretch it over the limits it was designed for. For example, I see no way serious sound application could be implemented with this API. Application that allows you to hear actually what you're doing. Like, so this is the async audio, asynchronous audio capabilities that HTML5 audio standard misses, and Mozilla extensions try to fill this gap. It's much more powerful, but it's not part of the standard. And we actually learned about this while hacking, and it's definitely much more fun. It allows you to generate a raw bit stream that is pushed into the sound playing stack. So you play with bits and you can generate tones and mix signals by, means of addition. So it's pretty cool. But next time maybe. If you have any questions, which I doubt, but here I am. Oh yeah, great.
I just want to mention that on the topic of the Mozilla extensions and things like that, I believe that there's an extended API being developed, or is being standardized, which is called the Web Audio API, and it's also part of Chrome, I believe.
Well, great news. Yeah, I have some resources here. So link to HTML5 specification, link to GitHub, and live demo of the app in question. So, Pavel? Well, yeah, it's supposed to be, but only if you try to play in the not overstretch the capabilities of Audio 5 API. Like if you try to run this in Mozilla, it will not be that great. The basic features are the same. You can play, but it seems like Mozilla has more bigger delay, so it does not allow for such a timely triggering of sounds as Chrome. Yeah, thank you guys.
Okay, so last up are Shane and Noel. We're going to talk about the photo tag app. What are we doing?
Thanks, Sean. Okay, when the hackathon started, pretty much started with going around the room and the guys looking for ideas for what to do with HTML5. And sort of one of the areas that we had identified was HTML5 is sort of quite suited to the mobile and sort of that space for numerous reasons. The first key thing is that HTML5 does provide hardware support that websites can't access some of the hardware on the phone, for example, the camera. The other key feature was the geolocation. Again, for the usability of some of the apps, HTML5 has sort of added new HTML components in there, the likes of Canvas, and then the other key feature which sort of supports mobile side is the offline development, likes of the internal database and other such capabilities that are available in HTML5. So really, looking at those sort of benefits of HTML5, we sort of went to look at what idea can we use some of those components to create an app within for mobile. So our core idea was basically to use some of those components, the geotagging, the canvas, and the camera functionality to create an application in HTML5 which basically allows the user to quite happily go around any location, take a photo, and that photo gets simply tagged to that location. To complement the mobile app, we also came up with the idea of a server-side app, or a website app. So really the two of them are going to complement each other. Obviously people go around on the phone taking the photos, and the core website app is there for anyone who wants to simply come onto the site and see what photos have been taken in which area. Okay. First thing is just around the architecture of how we put it together. First thing obviously was the HTML5 app on the mobile. The other thing was the core website browser. That's all being supported by a Java app server which stored the files and the geo coordinates within MySQL database. We also used the MySQL database just to handle the proximity searching. So given any given latitude and longitude, it can, pretty much retrieve photos within a certain range. Okay, I don't know if any is aware, there's a nice toolkit out there to support the idea of providing HTML5 applications for mobiles. The toolkit is called PhoneGap. What PhoneGap allows you to do is allows you to create a HTML5 website. And what PhoneGap will do is it will wrap that website within an embedded application for your chosen phone, whether it's the iPhone, your Android, your Ovi. So we thought that was quite a neat feature. So users get the perception that they're actually downloading an app, and that with the HTML5 capabilities, you're giving them the experience of an actual native app on the phone. So how PhoneGap does this actually is it embeds a browser within the application it provides to the user. It gives you two options. One option is to provide the HTML within your application, and then the second alternative is it allows you just to hit a remote HTML site. So obviously for speed and download, the embedded HTML is the better option, but for updatability, using an external site is the better way to go. Okay. We pretty much spent all weekend working on this, and we started to discover a couple of things in relation to HTML5 and the mobile platform. The first thing was, some of the key stuff around the geotagging, canvas, all that worked quite well on the mobile and gave, a nice user experience. Second thing, on the negative side, what we actually found was some of the hardware, capabilities that are a feature in HTML5 just didn't behave as we would expect it, and really it was unresponsive on some mobiles that we tried it on. So really what that left us was then taking a review of our whole application. Is HTML5 at this stage ready to take, capability of full hardware on phones? So, that sort of left us sort of trying to take a step back and take a look at it. So I suppose things that we realized and things that we suppose outcomes that we took was, for HTML5, although the mobiles are a great platform for it because their browsers are all up to date, really the next stage for it is really to see a full stabilization of HTML5 on all mobile platforms. As I said, because of the problems we had with the HTML5 app, particularly around the camera, we actually moved ourselves to developing a native app after the hackathon. So Shane's now going to just run you through what we did there.
Okay, that's a preview of the home screen, what you'll be seeing when you first open the app. That's after you go to take a photo. So it will, you'll be able to put in a comment, and then you can take a photo. And once you take the photo, this is it's the sort of preview of the photo and your description to get ready to upload it. So that's what you'll get. That's the success message after you have successfully uploaded the photo. So it will show your photo on the map just below there. So that's just a preview of the desktop client. As you can see, it gets your location and it puts a pointer on it. And as you can see on the sidebar on the right, at the moment we haven't got it finished, but that will soon display photos that were taken near you. So that should be implemented soon. So basically that's what you'll get when you search for a location. It'll show a pointer of where you're at, and it again will show photos that were taken near there. So some more information there. The development is almost complete, but you can have a look at our website. It's up there. The app code on GitHub and PhoneGap, the framework we used, up there. So we'd like to thank the developers who helped develop the app. So any questions? Basically what you do is when you're developing the mobile application, basically all you have to do is include the framework in your native app. Then the whole app is developed in JavaScript and HTML. So if you don't even need to know any Java or Android development really, because there's a whole walkthrough on the website. But if you know HTML and JavaScript, then it's easy.
We haven't looked at that, but
I think it is supported, yeah.
Okay, thanks, Alex. I don't know what time it is. It's just 20 to 9. So I think we'll just wrap it up there. I had notices on the agenda, but I can't think of any notices say that we're going to have the next session last Tuesday of September. I don't know what date that is. Maybe the 20. Do you know what it is there on? 27th of September. We haven't really sorted out the agenda. There's a few things that are being bandied around right now. One of the ideas was to do a comparison of different cloud platforms. That may or may not happen, but we'll see. You'll get notification on the mailing list if you sign up to us, or you can follow us on Twitter. As usual, we're going to go to the schoolhouse for a drink if anybody's interested in having any further discussions on any of the topics that have been talked about today. So hopefully see you next one, guys. Okay, everyone get back their badges as well.
Is out of the bridge?
That should do it.
Yep.
I should press system off, but I
Yeah.
think that'll turn off the lights as well. won't it?
No, probably.
try.
I don't know.
No, I guess
fine.
not.
Okay. Righty. Was not a long one today.
Yes.
Yeah. Hey, how you doing?
Good. We have to maybe if you have a look at the Google app one page page. I ran into a problem because I think I clicked task, okay, and I added more cameras.